Yeah, I know that number sentence swap took some thinking, but you did such a good job at it. Okay, so now we're on to our application problem, which is, as always, in your Learn book, which has the flower beds on it, on page number 185. Learn blue, page 185. 185, those are the digits. That's the order in which you're looking for that number. And then we'll go ahead and read the problem. Marcus has 9 strawberries. 6 of them are small, the rest are big. How many strawberries are big? It says fill in your template. My template, what's that? The same template we used yesterday, you're going to need it again today. Look, it's even pictured. But guess what? If you haven't found the page yet and you're just listening to me, look at this. Look what they did for you. They put it in the box. Wasn't that so nice of them? So it is already in the box. So if you're confident and you want to work straight on the page, you can. If you feel you want to practice it a little bit, like hopping back, go ahead and use your whiteboard, because you're gonna need that today anyway. So, okay. All right. So here we are. You're going to circle the mystery or unknown number in your number sentence and write a statement to answer the question. So here is my picture, and here is our question, and you work for 3 minutes, and then we'll work together. All right, so Marcus has 9 strawberries. 6 of them are small, the rest are big. So they gave us this problem in a whole split part, small, big. So we'll start with our whole. Marcus has 9 strawberries. 6 of them are small, the rest are big. Okay, so let's write our subtraction sentence and our addition sentence, our missing part. 6 plus, so 6 small strawberries plus some big strawberries is equal to 9 strawberries. Okay, using our number path, starting with our whole, making 6 hops back. Sound familiar? So starting with our whole, 1, 2, 3, 4, 5, 6. Where do we land? We land on 3. So we'll say that 3 is the missing part. 3 is the number of big strawberries. Writing our subtraction sentence that matches the problem. Marcus has 9 strawberries. Take away the 6 small ones. We found that that rest is 3 big. 6 plus 3 is equal to 9. Notice, same numbers. So in answering the question, how many strawberries are big? You need your word answer. 3 strawberries are big. There. 3 strawberries are big is the complete sentence answer to this question. The minimum of words you need is 3 strawberries. You need a number and you need an object. A word problem without a word answer is wrong. Every time. A word problem, no word answer, something is wrong, something is missing. So 3 strawberries. Alright. So you notice in this problem and how we did it, we took a lot of hops counting back. I'm tired. I want to show you something today, and it is, I want to give you the option to choose to count on or count back, okay? And it depends on which direction you need to go. There is a way in which you can go from part known to whole. I'm going to show it to you. Hold on. So keep your template, your whiteboard with with this frame in it that you have. And we're going to look at a few problems. We're going to look at a few problems together. Okay, so just here's my template. You don't have these first few. It's okay. I don't want you to have them. So, in this strategy, thinking about that same problem we just did, where we knew the whole was 9 and we knew the part was 6, and we were looking for that missing part of 3, correct? We just did this with the strawberries. What we did the last time was we went from the whole 9 and we hopped 1, 2, 3, 4, 5, 6. So we counted the hops to find the missing part. What I want to show you now, the other thing you can do is you can hop up from the part you know to the whole. You can go part I know plus however many hops it takes me to get to the whole. How many hops did it take us to get to the whole? 1, 2, 3. We made 3 hops counting up to the whole. So you can either go from whole, hop back the number of hops for the known part, or hop forward from part known to whole. Does this result in the same answer? Is it landing on 3 and taking 3 hops? Are those the same? Yes, because we still find that 6 and 3 are the parts where our whole is 9 in the case of these strawberries. Let's try another one. So we count back, we're counting these to where we land, and we count on, we're counting the number of hops. Let me show you, okay? I have here 9 minus 8, which means in number nonsense, my whole is 9, my known part is 8. Watch this. I'm going to show you counting on. I'm going to start at the part I know, and I'm going to count the number of hops it takes me to get to the whole. 1. From the part I know to the whole was 1 hop. Is 9 minus 8 equal to 1? Well, let's put 1 in this number box. Let's write a number sentence, an addition sentence that we're familiar with. 8 plus 1 equals 9. Huh, that checks out. I know that. I know that's true. If you're looking at me like, whoa, 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 I just got the other one. You can still do that too. The question is, which one is more efficient? We can still say, starting at 9 and make 8 hops. 1, 2, 3, 4, 5, 6, 7, 8. Did we still land on 1 as the missing part? We did. 1 is still the missing part. Which strategy takes less steps? Depends on the problem. 1 hop or 8? Which one are you less likely to lose track? 1 or 8? 1. Oh, however, it is a matter of preference. Some are not comfortable counting back. Some are not comfortable counting on in subtraction. But just like in addition, where we flipped the parts to put the big one in our head when we were counting on instead of the little one to count on, we're doing the same thing, only with our number path for subtraction. So start at the whole and hop back the number of hops we know for part, or start at the part we know and hop to the whole, part to whole, 1 hop. Let's try a different one. Okay, that's the game. How about I have 7 minus 6 so far. Which pieces of my number bun can I fill out? Yes, my whole is 7. A part is 6. I don't know this part yet. Let's try counting back first, okay? Starting at 7, we're going to count back how many hops? 6, okay? 1, 2, 3, 4, 5, 6 hops. Count it back. We land on 1. That's the correct answer. Good. Now, let's try hopping from part known to whole. What is the part that we know? 6. And what is our whole? 7. Let's count on or hop up to the part we know. 6, 7. Oh, how many hops was that? How many hops did we make? We made 1 hop. Is that still the same correct answer? It is. Do 6 and 1 make 7? They do. 7 minus 6 is equal to 1. We also know that 6 plus 1 is equal to 7. Because 6 plus 1 is also equal to 7. So in the case of which one do I choose? Well, which one has less hops? Which one is easier? Okay. Let's proceed to some examples in your book that you can keep to see for reference. Let's proceed to some, let's go to some examples in the book so that you can look to see them for reference. Alright, so this is, yes, a number path, yes, number sentences. 113, 113, red number, red trim book, bedrooms. Notice the homework book has a bedroom scene because in theory you do the homework at home under normal circumstances. So yeah. So page number 113 looks like just what I have on the board. And for what we see here, we're given the whole and a part, we're missing a part. Let us set up our 2 number sentences, 1 addition, 1 subtraction, with the missing part. Let's start with the familiar. 3 plus blank is equal to 10. And then now let's write the unfamiliar. 10 minus 3 is equal to blank. Notice what I'm doing. I'm moving the missing part so that it's either, so it's from leaving the middle and going to the ending. So we're still using the number path. Should we count on? So should we hop from the part to the whole, or should we count back from the whole? I said that backwards. Should we count on from the part to the whole, or should we count back from the whole to the known part? Let's try both, okay? Let's start with the whole and count back to the known part. 1, 2, 3, 4, 5, 6, 7. I made 7 hops to get to the known part, which means my missing piece is 7. Whew, that's a lot of hopping. Let's try it the other way. Let's hop from the known of 3 to the whole. 1, 2, 3, 4, 5, 6, 7. It's still the same 7. Did either strategy prove to be an easier problem this time? No, so like I said, you have some choice in which one you prefer to do. Okay? Okay. Alright, let's do the same thing with this other way to make 10 here. So this one, I say that I like to count back. I preferred counting back on this one, going from whole to part known. Okay, let's look here. 10, 6. Let's write a number sentence. 6 plus an unknown is equal to 10. 10 minus the known 6 is equal to the unknown. And how do you know when you walk over that right finishing? So 3 plus 7 is equal to 10. 10 minus 3 is equal to 7. I think for this one, we should count on. We should start with the known part and hop to the whole. So from 6, how many hops to 10? 1, 2, 3, 4 hops to get to 10. Recount on. 6 plus 4 is equal to 10. 10 minus 6 is equal to 4. Good job. Alright, so then now let's solve the number sentence and pick the best way to solve. Still using our number path. You have your board. I've got my big board. Look how close these numbers are to each other, 9 and 7. Should I go forward or back? I should go forward. I should start at the known part 7 and hop up to the whole 1, 2. How many hops did I make? 2 hops. 9 minus 7 is equal to 2, and we went forward. We counted on. 8 minus 2 is equal to blank. Well, this time, let's count back. We're going to count back this time and watch what happens. We're going to start at the whole, and we're going to hop back the number of hops it suggests. 8 minus 1, 2 lands us on our other part, which is 6. Good job. How about 7 minus 5? Should I hop from 7 to, should I take 5 hops from 7 to 7? 1, 2, 3, 4, 5. Or should I hop from 5 to 7? 5, 6, 7. I should go forward. I should count on. Good job. I should hop from my known part 5 to my known whole 7 and count the number of parts. Known part 5, 1, 2. Known part 7, known whole 7, we made 2 hops. Good job, guys. Excellent work. Okay, so now your job is to work on your problem set, which mirrors what we just did from our homework book. It's on page 187 in your Learn book. When you're done working on your problem set for a good solid 10 working minutes, you'll click on the next, you click to the next one, and then you will go and complete your exit ticket. You'll complete your exit ticket, okay? And in this one it says, Ben thinks you should count back, Pat thinks you should count on. Which is the best way? This is an opinion question. You need to indicate your opinion. Make a math drawing to show why. So what you're going to need to do is you're going to need to write your answer. You're going to need to write count on. If you pick that, you're going to need to write count back. If you picked that, so pick one and show why. Pick one and show why. Of course, you already know. Let me know if you have any questions. I'll do my best to help you remotely, wirelessly, all the ways. But see you later. Bye.